What we're going to do in this lecture, we're going to begin by taking a look at a chart that you can use for doing heating, ventilation, and air conditioning calculations. Basically properties of air mixture, so air and water vapor. And there's a bit of a shortcut, and that's using this chart called the psychrometric chart. If you recall from last class, what we did is we looked at a number of different equations that enable you to calculate properties of air, water, vapor mixtures. They tend to be a little involved. The psychrometric chart enables us to determine many of those properties in a kind of a quick and efficient manner. Now, one thing that I should make a note of is this psychrometric chart only applies for specific pressures. So that's an atmospheric pressure. So typically the ones that you'll find in a textbook will be for 1 atmosphere. But if you live at a higher elevation, for example, then you would need to have one that is specific for your particular elevation. So that is the psychrometric chart. What we're going to do, let me provide a little bit of an introduction to what this chart looks like. And so what I have here are basically different representations of the psychrometric chart. We have the dry bulb temperature on the lower axis. And then on another data set we will add will be the specific humidity in grams per kilogram of dry air. Then we have wet bulb temperature shown in those blue lines going to the upper left. Then we can add in the relative humidity going from 0 to 100%. And then we will have the specific volume of our air mixture. And then finally we have the enthalpy in kilojoules per kilogram of dry air. Excuse me. So that is the psychrometric chart. Now what we're going to do, we're going to work an example problem involving this chart. So there's our problem statement. What we have been told, a couple of points here. First of all, we're dealing with room air at 1 atmosphere. So that gives you a bit of a hint that it means that we can use the psychrometric chart. And we're told that the temperature of the air, that would be the dry bulb temperature, is 32 degrees C. And we're also told that we have 60% relative humidity. And from that, they want us to calculate a lot of different things. First of all, they want us to get the specific humidity. So that, if you recall, is little omega. Enthalpy is H. Wet bulb temperature is TWB. The dew point would be TDP. And then finally, the specific volume of our mixture would be nu. So what we're going to do, we're going to go and read the values off of the psychrometric chart in order to obtain these values. And what you'll see is that it's quite a bit more efficient than using the equations that we saw. Although the equations will apply for whatever atmospheric pressure you might be dealing with, whereas a psychrometric chart only works for whatever particular pressure, and the one that we're looking at here is for 1 atmosphere. So let's begin. We're dealing with 1 atmosphere. I'm going to use the red pen in order to indicate things on this. And we begin with a dew point temperature of 32 degrees, sorry, not dew point, dry bulb temperature. And so that brings us in down here. That is our 32 degrees C, which was one of the pieces of information we had. We were also told that the relative humidity was 60%. This is the line for the 60% of the relative humidity. So what I want to do is walk up this line here, and where it intersects with the 60% relative humidity, that's where we're going to pull our data from. So what I'm going to do, I'm going to put a blue circle around that so you can see it. Now what we need to do is read the different data sets that are on here. The first thing they want us to get is the specific humidity, and specific humidity is the data that's plotted over on the right hand side, and this is grams per kilogram of dry air. And so if we go over to the right, we'll find that we get to 18 is the value. So that means that we have 18 equals 18 grams per kilogram dry air. And usually we put this kilograms per kilogram dry air. And so with that, we would get 0.018. So that becomes our specific humidity. The next thing they want us to get is the enthalpy, and enthalpy are the green lines going up. And so here are the enthalpy data on the side. So if we move our way up here, we find a value somewhere around 79. So that's kilojoules per kilogram of dry air. Next thing they want is the wet bulb temperature. So wet bulb temperature, you'll notice that's the line that I've kind of written over the words, but these are the light blue lines that are going to the upper left. And so wet bulb temperatures, we have 10, 15, 20, 25, 30. And so for this particular case, we can see that we're between 25 and 26. So let's say we're at 25.5. And next thing they want is the dew point. The dew point is the temperature at which water starts to drop out. So we're lowering the temperature, and then we get to the saturation point where water starts dropping out. That's when you get condensation, moisture, dew forming, on a morning on your car, for example. So in order to get that, we're not changing the specific humidity, but in order to get dew point, we're dropping the dry bulb temperature. So for that, what we do is we move directly to the left, and we get to this point here, and we then go down to read the temperature for that. And so that comes out down here. So that's 21, 22, 23. I would say the dew point temperature then is about 23 degrees C. And the last thing they want us to extract is the specific humidity. Specific humidity here are the curves for specific humidity. They're the red curves that are moving up and to the left. And we have 0.94, 0.92, 0.9, 0.88, 0.86, and goes on and on down. But we can see for the particular case that we're looking at, we're right at about 0.89 would be our specific volume. So we can write 0.89, and that is going to be meters cubed per kilogram of dry air. And so that demonstrates the use of the psychrometric chart. You can see it's quite a bit easier than using the equations. It's quite efficient, and we will be working an example problem later in this lecture using the psychrometric chart, applying it to some sort of HVAC process. So that ends this particular section.